Holy shit! I don't think I've seen it go below 1 minute before. I didn't know it could go in second.
I was very curious if it would go to second.
Yeah, I thought it would just always round to a minute. Like I thought.
No, I think when it says a minute, it actually might be as high as 2 minutes. So we're doing better than ever.
Wow.
And technically, it's actually 54 seconds right now. So out of date slides.
Out of date.
Wait, how do you actually see that? Because it doesn't show on my piazza.
It's in like the bottom right or something.
Oh, I collapsed it. Oh, that's why. Okay. Cool.
Wait, where are we putting the times for milestone 1 makeups?
Well, they're scheduled like ad hoc with us over Piazza.
Oh yeah,
we should probably
I
put them
DM'd
into
them.
the main spreadsheet just so that we can make sure there's enough staff there.
Okay.
Justin and I have got it, but yes.
Do you like when you schedule it, like make a new sheet up like in the same one and just put the makeups there?
Do we really
a new
throw
sheet?
of
Oh,
our-
not a new sheet, or like just at the bottom.
Yeah. Okay.
Are we really flexing our response time on the Zoom slide here?
Yeah. Encourage the use of piazza and staff.
I respect it.
Wait, Oshkosh, can you reload the slide? I just made a note
Yes.
about the.
What change? Oh, I see.
Yeah, just the stuff about the private rooms. Alrighty. Do you mind if I start screen sharing? And then we can get started. I can just do it. Alrighty. Cool. All right, everyone. Happy Friday. So just a couple announcements as people are kind of joining the class. So remember milestone 1, you have to sign up for a 15-minute slot tonight by midnight tonight. And basically you're just gonna meet with the staff and kind of come prepared with some wireframes and talk about what idea you wanna choose. And if you're like in a time zone that doesn't work for you, or if one of the times doesn't work for you, just make a private piazza, and then one of the staff members can help accommodate you into a different time slot. Milestone 1 will be on Gather, and so there's a sign-up sheet that's linked on Piazza. It says like pick your milestone 1 slot. We created a couple of study guides and resources for you all that are on Piazza. There's a React study guide that's really well done. There's also a bunch of Figma resources that are compiled. So definitely use those when you're going about milestone 1 or starting your project. Today we're going to be doing 3 workshops. They're all going to be on the Catbook React folder, so you don't have to reclone it and create a new folder. We'll be using the same one, so make sure you have it set up and ready for VS Code. And if you still have issues with that, definitely ask the staff. And lastly, 2 last things. Make sure you use Piazza. We have an under-minute average response time, so definitely send your hardest questions to the staff and see if they can answer them in under a minute. But really, Piazza's here really as a resource, and we really want to help you guys out. So if you have any questions, ask on Piazza. There's a help queue, so if you ever get stuck during any of the workshops, use any of the breakout rooms 22 to 28, and you can join the help queue at web.lab.2/queue. We also have a questions document. You guys are pretty much familiar with that. If you have any questions, put them on the document. And then we have bonus office hours tonight from 7 to 9. So if you need any last minute help on wireframes, if you're confused about React or APIs or any of the material we're going to go over today, definitely come by. So why don't we get started with today's lecture? So today we're going to actually start talking about backend, right? So we've been talking about React for the past couple of days, HTML, CSS, all of that's front end, and that's kind of like the visual stuff that you see on a website. And now we're going to start transitioning and kind of talking about the inner workings of our website and talking about setting up your Node.js server. So just to start off, can anyone tell me what a server is? Kind of one of those questions that like, oh yeah, we know what a server is, but then like when you think about it, it's like, wait, what actually is? Holds data, hosts your website, stores information, store your data, computer gives you data. Nice, nice. Yeah, so you might have heard of a server in the form of like a Discord server, or in the form of a Minecraft server, right? Or maybe you've used Xbox Live. Maybe you're thinking of like these large data centers that have a bunch of powerful computers, or AWS handles other cloud computing software that you use, right? But really, at the core, right, a server is just a machine. It's a computer that is running a program constantly, right? And when this computer, right, just represents, or server represents this machine. And your client is your computer, your phone, your iPad, right? Anything that you're using to view a website or interact with a website, right? Or interact with any app, right? And the way it works is that your client sends a request. So we send a request over to the server. And then the server will recognize that a request came in, it'll process it, and it'll send a response back to the client, right? So it seems like a pretty simple design. And one thing that, about servers is that you can have multiple clients that communicate with the server. And so yesterday we had like over 200 students all talking to the Heroku server, and then like we broke Heroku, right? So that's like a little bit more intense. We don't have to worry about that level of scalability right now. We're just kind of working on setting up your initial server for you to run your API. So a couple reasons why we need a server: file access. So I think someone said in the chat, files can hold like your web files, it can hold Any other files you might need, they might host images, right? So that's kind of one thing that we use servers for. Centralization. So if you think about yesterday, we were all writing comments on one Catbook post, but basically, like if I send in a request to post a comment and Kai sends in another one and Noah sends in another one, right? The server basically needs to compile and put together all of our comments together in a shared piece of data, so that way it's all centralized. And then when we try to get all of our comments, all three of them are there. And lastly, security, right? When we get into this later on, when we start talking about authentication or passwords or API keys, right? All that is private and sensitive information that you want to make sure you store correctly on your server. And we'll kind of teach you how to do that. So another thing about servers is that servers, when they run on a machine, they actually bind to something that's called a port. And so here's an example port, right? So a port is just like a number. So think about like, if your computer is a hotel, the port is like the hotel room. It's basically telling like where on the machine it's running, right? So you've probably already started using your hot loader, and the port is just the number after the colon, right? When we run the hot loader, it's at localhost 5000, so it's at port 5000. So that's just one thing to keep in mind about servers. And so this is pretty much the standard like format of like when we're communicating with the server. We have the protocol, and then we have the domain, and we use the port afterward. And so why does anyone know? This is kind of like a bonus question, but why don't we need to specify the ports for most websites? Like when we do Google, we don't have to do google.com colon a number, right? And just for, oh yeah, okay, so someone kind of gets it, yeah. So we do actually connect to a port, but we don't have to write it. And that's because there's already reserved ports on our machine that can handle HTTP or can handle SSH. So you might be wondering like, why do I do just google.com? Why does that work, right? And it's because there's already ports that are reserved to handle certain processes. That's just all you need to know about ports. There's probably more online that you can go into, but for now, just know that it's kind of this like a server binds to a port. That's the most important part. So what we're actually going to be doing is you're going to be using your own machine as a server. So every computer can run its own server code, and we have a special domain, and we've already started using it with the hot loader. We go to localhost. So we're going to be using the same domain localhost, but we're just going to be using a different port to run our server. So remember that like your machine is kind of like this hotel, and then the port is like the hotel room. So it tells it where to run. So when we go to like on a localhost 3000, that's basically saying that our server is running on port 3000. So yeah, so how do we actually write server code, right? This might be, we've been talking about what a server is, but how do we actually like implement it, right? Well, it turns out you can write a web server in a lot of different languages, and you may have heard of a couple of languages already, like Flask, Apache, Express, Django. There's a lot more that exists out there, right? But for purposes of web.lab, what we teach in this class is Express. We teach Express.js. It's in JavaScript. And when we run our Express server, we actually need a tool to run JavaScript. And you've already been using this tool, but you might not have fully recognized that you've been using this tool. So we use Node. So Node is basically what allows us to run JavaScript on our machine. And Express.js is what allows us to structure our JavaScript. And it's specifically how we're going to be structuring our server and API. And so Node uses a bunch of packages. And so we use Node Package Manager, which is short for NPM. So anytime we tell you to run NPM install or NPM run hot loader, what we're using this command that's Node Package Manager that basically handles all the dependencies we might need, and it tells us basically how our app runs. And so whenever we use these dependencies, right, like if you remember from yesterday, we were importing the reach router library, but we never coded reach router, and we imported a link, right, but we never actually wrote that, right, because what we're doing is we're actually importing that from an external package, external code. And the way that it knows how to do that is in the package.json. So it might be a file that you saw. All you need to know is it just holds metadata for information about our project. And that it actually holds like the script. So when we run npm run hot loader, that's kind of what we define what run hot loader means. And specifically, it has this key in our JSON that's called dependencies. And when we run npm install, it'll basically go through that list of dependencies, and it'll basically install each package and put it in a folder called node modules. And that's exactly where the reach router module was from yesterday. So that basically handles all of our imported code. So why don't we get started with the workshop? So if any of that might have seemed too fast, we'll explain more of it through the workshop. So I'm going to give you guys maybe like a minute and a half to get this set up. So open up VS Code and open up your Capbook folder in VS Code. And then you want to open up 3 terminal windows. And I'm going to explain to you, right now, I'll just have 3 open and make sure they're all at the Capbook React folder. You can either do this by opening up a terminal window in VS Code and just opening up 3 windows, or you can have your own separate terminal using the terminal or whatever command line you use and opening up 3 windows of that. But if you do it in VS Code, it's automatically navigated to whatever folder is in your VS Code. So it'll be Capbook React. And then you can run these commands, git fetch, and it basically fetches any remote branches if there were any updates last minute. You're going to check out to W4 starter. So we're on workshop 4 now, and you're going to run npm install. Do you need to run, if you have any changes from yesterday, yeah, why don't you run git reset hard? If you have any changes from yesterday, you should. If you're on the complete branch from yesterday and you haven't changed any of the code, you probably don't have any changes. You can run git status and it'll tell you what changes you have. If you want to, you can run git reset hard because eventually we're going to check out too. You should run it before we do the checkout. So try to be in between this step. I get the following unchecked. Please move. Okay. Can maybe join the help queue and maybe one of the staff members can help you with that.
I'm going to open breakout rooms. No need to join unless you need help.
Yeah, thanks, Kai. Maybe I'll give you like 30 more seconds to get this set up and then we'll move on. So opening up Capbook React in VS Code, open 3 terminal windows. They can either be in VS Code or you can do it in Capbook React or in your command line. Run git fetch. After you run git fetch, you probably want to just do git reset hard. Yeah, I didn't include it here, but yeah, you should run git reset hard. And then after that, do git checkout W4 starter, and then run npm install. So do all 3, do you need all of these steps for, oh, no, just do it in 1. Yeah, this all should occur in just one terminal window. Good question. Why do we need, that's actually a great question. We will explain it. So in your first terminal window, here's what I want you to do. Run your hot loader. We've been doing this since Tuesday, I think, or Wednesday. So it's npm run hot loader, and then open up a Chrome tab and go to localhost 5000. Remember, localhost is a special reserved domain that is basically our machine, and 5000 is the port number. So your hot loader is technically like running a development server. We just call it the hot loader, but if you're curious, that's what it is. So in your first window, open up npm run hot loader. Remember, if you still have it running from yesterday or from a previous version, you should only have it run once. So just kill any previous versions. If you get any conflict saying the address isn't used, that means it's running somewhere else. So you don't want to rerun your hot loader. You should only ever have it running once. So first terminal window is npm run hot loader. Your second terminal window should be npm start. So this is when we say we're going to run our server on our local machine, like your machines can run server. And then you should go to localhost 3000 in a separate Chrome tab. I don't know about that. If you have like specific errors, I can't really help you out right now. Maybe join the help queue and one of the staff members can help you out. But yeah, so terminal window number 1 should have your hot loader. Terminal window number 2 should have your server, npm start. And then the last terminal window is what we're going to be using for git commands. We're not going to run npm commands. And what you should notice is in the first 2 windows, it's constantly running and it's still open. So you can't run any new commands. That's why we have the third one to basically handle any commands that will finish. Why don't we just quickly look at our code base? So throughout this week, we've been working in the client folder. And that's basically where we've had our React code, components, pages, right? All of that front end, right? And then now we have this new new folder called server that's going to contain all of our backend code, and we're going to start building it up, right? And then there's all these other files here that that were just provided by the staff to configure your app. You don't really need to worry about them now, but if you have any questions about them, just feel free to ask the staff about them. And then remember, this is our node modules that was created when we do, oh, wait, okay, that's a good question. You guys are jumping ahead. We will resolve the cannot get slash, but that's where you should be. If you can see that, that means it works. Yeah, this is the server code that we're gonna be, so open up server.js, and I'm gonna do this step on my computer. So I'm gonna go into server, and we have server.js. And so all of this was set up, and here's what's happening is that this line right here, const express equals require express. This is how we access that node package. We use require, and we basically put the name of the package as express. So basically, we're just importing the express library. And then we're going to create a new instance of a server, which is how we call it, like app, right? App is equal to express. Let's just create a new express server. Remember, servers bind to a port. So we basically have to tell it what port are we running the server at. So we've designated 3000. That's why we say go to localhost 3000. So I'm going to do my terminal commands for you all. So remember, in the first one, we run npm run hotloader. And then I'm going to press this little like rectangle button that basically splits it so I can see it side by side. And the other one, I'm going to do npm run start. So on the left, it's doing the front end code, and on the right, it's doing the server code. And then I'm going to open up a new Chrome window that's localhost 3000. And it says cannot get slash, which for purposes of right now, this is where you should be. And we're going to slowly set up our server so it looks a little bit nicer. I'm going to put this over here. Okay. So if you have the cannot get slash at localhost 3000, you should be good for now. We're going to fix that. So we just went through the server file. We're going to implement our first endpoint. And so remember, yesterday we were talking about like endpoints for like comments or for stories, right? And we would pass in like different parameters into our API. And so now, and yesterday we were connecting to the Heroku server. Now we're going to be setting up our own local server, so that way you can see your own local changes, right? And you won't be able to see all the data from the class because now we're redirecting our app to point to our server. We're going to write these 3 lines of code in the server.js, and I'm going to walk you through what they mean because it might be a little bit confusing. First, whenever we have to have an endpoint, we have to specify what kind of HTTP method we're using. So this right here means we're using app.get basically will handle any GET requests. And then the first argument, so this is like a function. The first argument is our express route. This is a little bit similar to like the routes we use for routing in React, but it's a completely different port, right? So it's not communicating with React. So our express route is basically just like, what is the route of our endpoint? So we're doing /API/test. And then we basically create this function. It's called the function handler. And it's basically like the same notation that we've been using for any other function in JavaScript. And the way it works is that it takes 2 arguments, rec and res. Remember, whenever we're communicating with the server, the client sends a request. That's what rec is. And the server sends a response. So that's what res is. So we're passing those 2 in. And this specific line right here is actually our server response. So res.send. And we have to send some information. So we're going to send a JavaScript object that has a message that says, wow, I made my first API. And this is very similar to like a return statement, right? But we don't really have return statements here. We're just doing res.send because that's how it'll send something back to your client. So if you can implement this, then on your localhost 3000, edit the URL. So it's localhost 3000 /API/test. So I'll leave this here maybe for like 10, 15 seconds, but then I'll code it with you so you can see it. Yeah. Yep, you have your own server. So if you ever, it's on your local machine. So any request that your teammate makes, and that you're making, you won't see them because you're only communicating to your own machine. It's not when if you want to redirect it to like your Heroku server, you can, but later on we'll talk about like how to use a database, but don't worry about that for now. So I'm going to implement this right now for you all. So under here, we're going to do app.get. So we're writing a get endpoint. And the endpoint route is API/test. And then basically we have to tell the endpoint what to do when it reaches this route. So it's going to take a request, rec, and a response. We're going to write a function. And let me increase the size of this. And basically we want to send a JavaScript object. So that has a message, and it can be, well, I made my first API. And you want to hit save, and the server is basically watching for any changes. It's kind of like the hot loader equivalent. It's like a live reset of your server. So then if you go to localhost 3000/API/test, you'll see, wow, I made my first API. And so that's basically how you're communicating, right? But Chrome is making a GET request to our server at localhost 3000, and the endpoint that we're hitting is API/test. And then Express is receiving that request, and it's gonna basically define this endpoint that says, if you hit this endpoint, do this. And we told it to send a response that has a message that says, wow, I made my first API. So that's the first step. If you didn't get here, we're gonna move on to, and you should see that, we're gonna move on to the next step. So let's get on the same page. We're on get reset hard and get checkout W4-step 1. If you just want to stay on track, you can, but this is just to get everyone on the same page. So get reset hard, and then get checkout W4-step 1. Okay, so now we got to talk about error handling, right? So servers can run into a lot of issues. What terminal do we do this in? You should do this in the third one, the one that doesn't have anything running. The third, oh yeah, you guys are all on it. The third one is what we use for our Git commands. So error handling is something that's super important in React, or sorry, in our servers. It's also important in React, but today we're talking about servers. Basically what we need to do is write some kind of function that says, if the server ever encounters an error, we want to do something, right? So app.use basically introduces this concept of middleware, and we'll talk about it a little bit more near the end. So app.use will say, will take in 4 parameters, right? So remember before we were doing, this specific error function will take in 4 parameters. And we're basically defining a function that says, if you ever run into an error from when the request is received and before the response is sent, run this function, right? That's basically what use is saying. It's called middleware, so it's going to run in the middle. So this function takes in 4 parameters. We're only going to be using 2 of them. It takes in an error, request, a response, and then next. And basically, when we detect error handling, first we want to check the status code. So if you remember from yesterday, Noah was talking about status codes of 500 means the server messed up. It found a bug or a crash or something like that. So basically, we're going to get the status. And we're going to say, is the status we're going to create this variable that's like, it's either equal to the property status of error, or it's just going to be 500 if this is undefined. And then if it is equal to 500, we want to report it. So the way that we do that is we just do if status is equal to 500, console.log, the server encountered an error, and then we want to console.log the error. You don't have to copy like this word for word. It's just more visually, it's more visual for you to understand what's going on. And then we basically want to tell our client, we want to send a response that basically says, hey, we found an error and we couldn't really we couldn't do what you wanted us to do, right? You wanted to get all the stories, but there is an error. So we're just going to give you, we're just going to tell you that an error happened. So we're going to do res.status of status. And what this is doing is that it's saying res.setStatus. And it's going to basically set the status of our response equal to this variable that we defined. And then we want to send something back to the client. And so we're going to say res.send status, and it's going to be a JavaScript object. It's going to contain the status again. and then it's going to contain the message, which is error.message. I'm going to code this with you all. I know we're a little bit on time, so I'm just going to speed through this a little bit, but I'll explain it again as we do it. So app.use, that's like writing middleware, and we're going to create an error handling function. So it's going to take an error, a response, or no, a rec first, a response, and then next. And then we're going to write an arrow function. And then in this function, remember first, we want to define a variable that takes the status of our error. So error.status. But if it's undefined, we use these double bars that basically say assign it to 500. So it's kind of a nice, check for us. And then, so if we want to say if status is equal to 500, then we want to do console.log, error occurred, and we want to console.log what the error is. And then we have to send a response back to the server, or back to the client. So we want to tell it what the status code is. So we do res.status. Basically, it's like equivalent to res.setStatus. And we're going to include the status code, which is just a variable status. And then we want to send a response, which is a JavaScript that includes our status code of status and a message. And here we can just do the message property off error. And that's pretty much it for this function. Yeah, so why don't we get on the same step? You only ever have to code that function once, so if it still doesn't make sense, just check out to step 2, because I just want to finish this shortly, so Noah can move on, but I'll leave this here. So check out to step 2. I'll kind of leave this code here. You shouldn't see anything visually on your localhost 3000 yet. This is just more for for your client to basically understand that an error happened, right? So if something does happen, it's not going to return the error that it was supposed to, or return the response it was supposed to. So we define a function that basically says, return this instead. So yeah, so you should be on step 2. So you may have seen localhost 3000. It said cannot get slash, right? Doesn't look good. You guys might have been like, it's not working, right? That it technically is working, but what's happening is that we have not defined a route for just the slash endpoint, right? And turns out this can happen with any route that's not defined. If you try to do API/test1, it'll be cannot get /API test1. And that's because we haven't defined an endpoint for that specific route. So what we introduce is this catch-all endpoint, which is basically saying that if any endpoint that was not otherwise previously defined, it's going to hit this endpoint, right? This is pretty much similar when we were doing React navigation. It has we were telling the path of each page. So if the path equals profile, go here. If the path equals feed, go to here. But if it doesn't match anything, put not found. And that's kind of what the equivalent that we're doing here with this catch-all endpoint. And so when we hit this endpoint, we just want to return the bundled HTML file of our React app. And we can do this because it's already built for us, and we just have to, the server just has to send that file. So how do we do that? We're going to introduce a new package called path. So under line 17, write const path equals required path. And this is just another package that allows us to work with directory and file paths. So I'm going to do it here with you. So easy line. So const path is equal to require path. And then basically we have to navigate to the path of our file. So what we're first going to do is we're going to create a variable that represents the path to our React folder. So path.resolve is how we do that. So it's basically going to take in a bunch of strings that is basically the path to from where we are currently. So the commas represent the slashes, right? So dir name is where we are currently. So we're in the server folder. Slash 2 dots will take us 1 folder up to Capbook React. Slash client will then go into the client folder. And then slash distribution will go into the file that has the built files, right? So notice that this path just represents a folder. This represents our dist folder. And what we have to do is to basically send the file that's in there. So what we're going to do, remember app.use uses this middleware, and we're basically going to tell to Express to use this path, and express.static allows us to send files. So app.use and takes in parentheses, express.static, and then the argument is the React path. And this basically allows us to use that path to send a file on our Express server. And then, we got to use this endpoint. We denote it with a star. So you're going to do app.get with a star. And here we're only doing request and response. We don't need to do error index and all that. And the way that we send a file is instead of doing res.send, we do res.sendFile. So res.sendFile, and it needs to get the path to that file. So it's going to do path.join, which basically represents a path. And it's going to combine React path, which takes us to the folder, and it's going to take us to an index HTML file. So I'm going to do this with you, just because we're pretty much over time, but app.get of star, just star, you don't need the slash. And then it's going to take a request and a response. And we're going to do, rather than res.send, there's another function that we can use that's send file, and it needs to take a path. So res.sendFile, and the way that we get the path is we do path.resolve. Oh, I didn't even include the path. So we're just going to do const path is equal to path.resolve of dir name, and it's going to go 2 folders up, then into client, and then into distribution. That's the folder to the path. And then we're going to use app.use, and it's going to do express.static. And this is basically allowing the Express server to use the path. And then we're going to do res.sendFile, and it needs a path. So we're going to do path.resolve, path.join, my bad. It's going to be path.join, and it's going to join the, I'll call this React path. React path. And yeah, did someone ask? Yeah, I think that's what the question was. Yeah, good point. And we're going to do index.html. I don't know why. Did I have these? Okay. So now this allows us to basically send a file. I think, do I need one more? What's going on here? It's missing something. Root path. Oh, did I define path? I think it's define path. What am I missing? Path.join. Okay, this should work. I don't know. Okay. So res.send, we're here, app.get, send file, and here we go. Oh, yep, thank you. I was like, why? I renamed it React Path. Thank you for that. And it should run. So when you try going to your slash, it loads Capo for you. And this is like a different version of Capo. It should be whatever you have in your client folder. So that's fixing that issue. So the last step we need to do, so this is what you should see. Check out to the last step, and we just have to write 1 line of code. I'm just going to introduce this for you, and then Noah's going to pick up right where we left off. So this is what you should look. Remember, we included the Express and Path libraries, and then we created a new instance of the Express server. And then we wrote a GET request for API/test, and then React path. And then we basically created this variable React path that allows us to send the HTML files. So just a couple of things to know is that when you define your endpoints, they have to go from most specific to least specific. So API/test and API/star. And the star, remember the star is this catch-all endpoint. So the order in which you define them matters. And when a request comes in, it's gonna, if it's a GET request, it's gonna look at all the GET endpoints in the order that you wrote them. And it's gonna basically say, as soon as the route matches, then it's gonna execute whatever's in that endpoint. So if we do API/test, this function will run. But if we have this implementation, right, this API/star will still match because star can basically say anything after API, right? So it'll still hit endpoint B. Right now, the difference is that we just do endpoint A and endpoint B, but you could imagine that one endpoint gives you private information, like sensitive information, and the other endpoint gives you more just like the about page of your website, right? So it's super important that you define them from most specific to least specific. And that's why we put that like catch-all endpoint at the end of our GET request. So I'm just going to quickly go through this. So you might be wondering, when do we use 3,000? When do you use 5,000? 5,000 has your hot loader and it processes your React code, and 3,000 has your node server and it has your backend code. So these are two different ports. Remember that servers bind to a port. So to view your website, we will do localhost 5,000, and to view your backend and to test your backend, you do localhost 3,000. That's just something to keep in mind. So the last line that we need to do, so check out the step 3, and I'm just going to explain this. I won't code this because I'll show you what you have to write. It's just one line of code. But underneath app.express, we're going to introduce this app.use express JSON. So what does this mean, right? So remember, express allows us to write middleware. Thanks, Noah. App.use is how we define middleware, and middleware is just code that we run in between receiving a request and before we run the endpoint, right? So it kind of runs in the middle, right? And we use this library, or this express JSON parser middleware that basically allows us to make post requests, to write data to our server. And this parser will basically extract the data that comes out of it. So all you need to do is underneath line 20, where we define our instance of app, write app.use express.json. And that's pretty much it. That's the end of the workshop. I know Noah's going to pick up from here. We went a little over, but if you're still confused on the setup, feel free to ask questions in the questions doc. You can check out to the complete version of the branch, w4-complete. It's pretty much going to be the exact same as the starter code for the next workshop. So yeah, all you have to do is app.use express.json. So Noah, I will let you take over. But if you have any other questions, feel free to ask them on the questions doc. Yeah.
All right. Well, gracias, Nico. You definitely got the questions doc popping. So yeah, now instead of the specific server stuff, he at the very end there started to touch upon our specific API endpoints, but at this very moment, we only have one single actual endpoint beyond the wildcard catch-all endpoint. We only have the /API/test. And all that does is it gives us back a singular boring string. So we want our cat book to actually have more useful endpoints, ones that actually dynamically store and retrieve data. But to do that, we have to do some more fancy things. So we'll kind of get started in our terminal world with resetting, fetching. Let me use my pointer. Resetting, fetching, and checking out to the starter, which is exactly where we left off. Actually, I just copy and pasted it. So yeah, we will, if this doesn't block my way, get reset -- hard, get fetch, and get, see, look, I didn't even quite fetch up to the beginning. And hopefully with all hopes will be good. If you're not good, then we can, oh yeah, you can't see my terminal because I just shared. Let me fix that. I don't like Zoom. Zoom is not my favorite. I have to full screen Zoom again. All right, let's hope sharing just the whole screen doesn't backfire on me. But yeah, all I did was execute these commands anyways. So we'll just, I don't really have anything to explain. Nico did the hard part of explaining things for me. Thank you, Nico. So we can jump right into the actual code itself as much as you might hate it. So we're going to start in the API.js in the server folder, and API.js is a brand new file. Yes, thank you for asking. So we'll jump on over and we'll see that here in the server, we have API.js. And so what will we do in this file? Well, we're gonna define a few more routes. And we're trying to separate out our actual server code from our normal API code. So the first thing we'll do is we'll actually get our router going in this lovely file. So we'll have our const router equals express dot router. Ta-da. Don't you love it when libraries make things much, much easier for you? And from there, we want this router to be able to be used in other files, so that we can do a little more fancy things. We'll see exactly how we'll use it in other files here in a minute. But in order to do that, it's not quite the same as exporting our normal React files. In this case, we have our module.exports equals router to export it in this case. So we'll just add that to the bottom here. And with that, now we've caught our API.js up for now, but now we actually have to tell our server that our API is not in server.js anymore. So we have to tell, just like we had our server use this express, except instead of like a library now, we have our own internal library of sorts, our API.js. So we're gonna go ahead and import our API file into our server by using this require function here. So in server.js, we'll throw this right below where we had our express before. So I'm just going to throw this in here with const API equals require, if I can spell correctly today, /API.js. And so now our server knows that this API exists and will utilize the functions that exist within it when we actually add them. But we haven't quite added any endpoints yet, and but when we do add endpoints, we'll have to have the bottom thing. I think this Google Slides thing ends up covering the code repeatedly. But yeah, so just like with our API will be used as a middleware of sorts through this app.use, and so we can tell all of the routes that go to /API to instead be routed just simply to our API file. So to do that, we'll throw below our other app.use for the JSON. The order of these app.uses does indeed matter. So we're throwing it here such that the server and the post request JSON stuff runs before we add this. So next we'll throw in app.use. Yes, the API file will start dealing with this instead here very shortly. So the /API, anything that goes to /API will now instead go to this API file, which is kind of what we want. We want our separation of mind thoughts. We want all of our specific server stuff to exist in our server file and our specific API stuff to exist in our API file. So with that in there, we still have our one existing route within the server.js file, and we want this poor route to get out of our server. We don't want it here. He's not fun anymore. And so instead, we'll move it over into API.js and remove the one from server.js. But that won't be all we'll do exactly, as now the app is instead our router. And because all of our routes that exist in API are already mapped to this /API, we don't have to have the /API at the front, and instead we can just have /test. And so to do that, we can just highlight this puppy. We can cut. We can go over to API, and I'm going to throw it right below the creation of the router there. And instead of app.get, I'll do router.get. And instead of /API, we will simply have /test. And to make sure I've differentiated things, I'm gonna throw this little line at the end there. So hopefully, if we save both of our files right quick, and we have this layout in our API.js now, we should be able to test it out by having our in a terminal window here. We should be able to just run npm start, and so now I have a server running on port 3000. And so just like before, I'm gonna open up a local host thingy. So I can do local host 3000. And if I can type today, that'd be really great. But this Zoom share thing keeps covering up the address bar. /API/test. And so indeed, we've made things work again. So we have what Nico had before, but now it's in its own file. That might not seem just too useful to you, but you'll probably thank me if you end up adding 24 endpoints in your future web lab projects. If you already had start running, then you can probably just Control-C it and restart the npm start thingy. So now we are in a position to actually do the more useful things I keep mentioning, but keep pushing back further and further. I swear I'm actually going to eventually do them. I'm not just talking about voodoo magic. So yeah, if things are wonky for you, you can just go into terminal. I'm going to reset my current changes and then check out to W5 step 1. That way it also adds a couple beautiful comments. There's not really much to the comments, but here we are. And so now we can focus on our actual catbook routes. We've been dodging this bullet for a long time because it's kind of hard to set up your own server and API sometimes. But for starters, if we want dynamically stored and retrieved data, we kind of want to start out with some data we want to start with some place to hold data. Now, for now, we don't really have a database. Johan's going to cover that later today. But for the time being, since we don't have users or a database, we're just going to, at the top of API.js, we're going to declare 2 variables here, an object data to hold stories and comments, and a const variable to hold our username. It can be whatever you want it. I'm not going to use anonymous user, but so we can navigate over to our API.js, and just at the top here, I'm going to have const my name be Hackerman to match up with the slides. Additionally, we still not const. We want our data to be mutable. So we want data to hold two things. We want data to first hold stories. And stories will be more than one thing. So we're going to have an array here. And then we're going to add a stories object. And I don't know if you remember what the stories object contains. Do I have a slide that shows that? Part of this slide didn't load. All right, the stories object holds three values. We have the ID of each story, the creator name, and the content of each story, being a number and 2 strings respectively. Thank you, Claire. I'll look into that in a sec. But so for the time being, since this is the first of all of the stories, I'm going to give this an ID of 0. I'm going to give the name to the lovely Shannon Wu here, and then we will set not connect content to be the statement, I love corgis. I'm sure Shannon will tell you all of the love for corgis that she has. But not only that, we also have to contend with the comments. And the comments is almost identical to the stories, except that we also have a parent ID. And so we want this comment to be attached to this story. And so the parent is going to be the same as this ID. So we will go ahead and hard code in our comments real quick. Totally not me double checking. I don't goof this. So we'll throw in our one and only comment. So just like before, this is our first comment. So we will have one singular ID. And we also have a creator name. Jessica Tang is no longer with us, so I'm gonna give it to the other Jessica. As stated before, we have to make it match that previous parent. And then we want our content to be our generic, totally not deadpan stuff here. And so, wow, with all of that random hard coding, we've made a data object to store our data. This will be useful for you for all of 1 hour. Enjoy this so much effort for so little actual usefulness. Bam, reload. We're gonna refresh the page. We'll see if Google Slides wants to work with me. Yeah, so yeah, I use the username Hackerman. If you don't know what this is, knowyourmeme.com Hackerman, because you need to be cultured in this day and age. So moving on past the meme, Nico touched on this a bit earlier on what rec and res is, but to be a little more specific, more so in the practice of how we use it, our rec will be our incoming request. We will access its stuff through rec query and rec body, and there are quite a few other things in rec. If your IDE shows you all of the stuff within rec, go you. Res will be the server's response that we get to make in this lovely workshop. And res will send back an object, and we can also send back status codes with that object. And so now will be a more application of that idea. So we have our first actual useful endpoint that we need to make after all this time. So what does the /API/stories route actually need to do? So it needs simply just to send all the stories back to the front end. So this makes things a little easier for us. But first, I'm gonna ponder this question with you. How do we access all the stories that we've made? We literally just made something that holds all the stories for us. What is it? We're gonna sit here until one of you say it. Data, ta-da. Yeah, so we have all of the stories neatly held within data.stories. And so to send back all the stories in our API, all we have to do is add another endpoint. Instead of /test, we're going to have /stories that sends back the stories object. So over here in api.js, we will, below this test here, we'll have router.get, because this is a get request. We will have /stories, and it'll follow the exact same structure as before. We'll have the rec and the res. It would help if I didn't do the plus sign. I always end up doing that. And so all we want to do in this is to send back data.stories. And well, bam, we've made our first actually useful endpoint. If you want, you can now go to your localhost 3000, and instead of /API/test, I don't know if I saved this. There we go. So now that it's saved, I should be able to do /API/stories, and bam, we have our actual dynamic thing. Anything that I type in the data stories thing will be returned here as a JSON object. But I've been talking for absolute ages. And so now you guys have a chance to do something. But before I throw you out on your own, I should probably explain something. So yesterday during Claire's lecture, I think, we threw this thing in here, and you might not have understood exactly what it was, but hopefully by the end of the day today, you will understand exactly what it is. So this parent property is passed in with our GET request. And so it is part of our query. We want to access comments that have whatever the ID is for that prop, because remember, this prop was passed down from that parent story. So this is getting the comments that are attached to that story. And so we'll break down every single API endpoint for us, just to cycle this through and through, because you'll probably have to sit and do this with some of your later API endpoints. So we've said it quite a bit already, but this route needs to get you the comments that the story is attached to. And to break that down even further, first of all, you need to figure out what story the comments are attached to using rec.query. And then you need to filter out your comments such that you only get comments that are attached to that story, and then send back those comments. So now you get to do it. So your objective for the next little bit. You can go in breakout rooms if you need help. But your objective for, I'll probably give you guys a few minutes, is to add an API route below the slash stories one that gets the comments for a particular story. So you'll need to figure out what story they come from, what comments, filter out the comments such that they only come from that story, and then send those comments back to the front end. And here are a couple little hints to help in that endeavor. So we're just going to sit in sort of awkward silence. Feel free to spam the questions doc. I'll be paying attention to Zoom chat if you wish to lure me to Moon Pond. Just whatever. I'll be here for a couple minutes. Somebody shout at me if I've waited too long. Let's see how the queue's doing. Hey, that's a pretty clear queue. I need to see more movement here. Not to sound like ninja here, but I need to see some more movement in the queue there. That's not fun. Are you guys really not struggling at all? I mean, that's all more power to me, I guess. I guess I'm just the perfect professor here, but I doubt that's true. Yes, Tommy, I explicitly mentioned ninja by name. You know, there are a lot of people that blame the events of the previous year on the fact that nobody did the movement with Ninja. So if you want good 2021 luck, I better see some movement in that queue. I'll give you 2 more minutes. Flossed, brushed, mouthwashed, the whole 9 yards. Always good dental hygiene. All right, well, I think I've waited long enough. I don't feel like wasting any more of your time. If you're still struggling, there will be a chance to catch up not too long, and there's always help queue no matter what time of day it is. We actually ended up helping somebody in the help queue while we were trying to grade yesterday. That was pretty funny. So spoiler alert now. So we'll use the ID contained within rec query. We'll use filter and we'll send them back to the front end with res.send. So in code terms, we're going to have a little sub variable here within our normal API route to accomplish this. So we will, yes, as Tommy said, please don't join the help queue while we're trying to grade, but I just wanted to say it was a funny experience. Yeah, so now we can go in our code here and we can add the endpoint that we want. So we want our /comment endpoint here. More accurately, as the get endpoint of the /comment route. For our current purposes, those are the same thing, but we'll see here in a minute that those will start to have different meanings. So as I showed on the slide, we want to get the filtered comments, and all filtered comments will be data.comments.filter, and I'm going to do it this way, where we take a parent and we pass it such that the rec.query, and I'm forgetting if, yeah, we'll have the, oh, well, I messed things up. See, this is why live coding sucks. Yeah, so we'll, for every single comment, we'll have the comments parent be equal, and we're using double equals here for a specific reason. So when the ID is passed from the front end to the back end, it does weird type conversion stuff, and so triple equals will fail even though it has the same value. So double equals is unfortunately necessary here. Yeah, so here we have made our filtered comments object. And so now we can just simply res.send our filtered comments. Ta-da. So now we can end up, if we do start and hot loader, we can now look at this instead of just looking at it in our normal way. So I have start running here, and I'm going to, it would probably help if I saved these files. If we get a hot loader running, and not hot loaders, hot loader running in I'm going to let you guys handle the question in the chat. So now that we have a hot loader and a npm start running, we can go into Chrome and we can get localhost 5000 up and going. And you'll see that because we did all the front end work yesterday, this stuff, so on the front end made its request to /API/stories, and it made its request to /API/comment yesterday. We can see that the comments and stuff are working again. Except now you're actually on your own local computer are running the server for this. So now Heroku will stop hopefully crashing on us at every possible instance that it can. Can I show the code to give comments again? Yeah, I can. So all we have is the same setup of the /stories, except in between here, we're going to filter with the built-in JavaScript filter function that Justin, I believe, mentioned in his intro to JavaScript lecture on Tuesday. I mean, I get it. Tuesday was a really, really long time ago. Yeah, also be careful. It is /comment. It does bug me too. We should probably work on that. And just make sure the filter works out as it should. But assuming everything else is working together, you might notice one extra little problem. So if I go into Catbook here, we'll go to the actual Catbook, not a screenshot. If I go into Catbook and I want to type a comment, yeet, absolutely nothing happened. That's not what we wanted. So if I open the console, as any good developer will do when something bad happens, we notice something. There's a problem. There's this thing called a post request that didn't happen. So yeah, we've only made GET requests. We've only learned how to get data. We haven't done the work in order to actually create data. And so it's giving us a status of 404 because we don't have an endpoint. There's nothing to be found there. So guess what? We're gonna work on actually creating some data now. And so we're not happy. So what we can do now is if you're still having issues with the GET stuff, you can either give up or go to the help queue. If you still need understanding, I would definitely recommend not giving up. But if you feel you have the mental grasp, you can catch up to us with W5 step 2, which I'm going to do just for safety's sake. So git reset -- hard and git checkout W5 step 2. All right. So now we can work together to handle. So yeah, one extra little thing as a slight aside before we jump straight into post requests is Nico covered handling missing API routes for just the general case, non/API stuff. So one extra tiny little thing I kind of want to add in just to cover every little base is we can use this router.all. So all, just to verbally say it here, normally it will ignore if I made a post request to /API/test, it would still be a 404 even though I have something for that test. So this all will cover all of the potential HTTP methods and requests to it. And so we're going to add this router.all in order to cover our butts, and remember that we will add it to the bottom so that way we don't override some stuff. So we're going to add at the bottom router.all, and we will have the wildcard token to cover all of our potential routes that don't already exist. And so what exactly do we want to do when a route fails? So naturally, we want to inform them a little bit. So we're going to log the specific method and URL by which they failed, and then we're going to send them a 404 status code. So we'll have our console.log. We're going to do the weird tick thing. So we're going to say API route not found. And we're going to tell them the, this notation bothers me, but it works. So we're going to tell them the specific. So now we're going to use rec for once. So rec has a method, and rec also has a URL within it, and that we can both access. Now that we have that made, we can also set our status real quick. So we're going to set res.status to 404, and then after that we can append the send of a object, and we will say API. This is not just the most useful of messages to send back, but we'll send them back with the message that the API route is not found. And this should cover, if I save this real quick and go over to Chrome, I'll have to be a little bit quicker as we're running a little low on time, but we can do web.lab time. I'm sure you love the idea of web.lab time. So yeah, if I do /API/yeet, it does indeed give me the API route that it's not found. That's what we expected. We're all good. So now we can jump back into the train of post request stuff. So we kind of covered the post body yesterday on the front end side, but today we want to cover the back end side. And the back end side, we just, as before, we sent the parent when we add a comment, and we also get the content when we add a comment, value being the text of what was ever in that text box for typing our comment. And so we can see that the request that we end up getting will have our ID and the text that they wrote to us. And so this notes our difference between rec query and rec body. So for post requests, we're less worried about the query and more worried about this body here, because this body will contain the data that we wish to make. So as before, I'm going to cover the stories thing. So we first need to figure out what data needs to be saved. We need to put it in a structure that we've already defined, and we need to add it to our data object. So what I'm going to do is we're going to have a /story endpoint for the post. And it's going to have, just as in our data.stories, it's going to have the same thing, except actually we're going to fill them in with variables rather than hard coding them as we did before. And so it'll take a structure very similar to what we had before. After these get requests, I will add this router.post. And it will be a post request to /story. And just like with the get requests, there's not a difference in that regard. It will have that. And so we're going to define the structure of our the thing we want to save. And so our first thing, we want the ID. In our case, we're just going to make the ID the number, the biggest number, the number of actual stories we have. And so a shorthand way of figuring out the number of stories that we have, one more than the number of stories that we have, is data.stories.length. Ta-da. Creator name, this is why we ended up defining that my name thing earlier. And content, we know where to get the content because we know what rec.body.content has in it. And you'll see that matches what we got in the slides. So from here, we can first add that on to our stories. Otherwise, our internal story list never changes. So we're gonna push my story into the stories object, and then kind of as convention to actually send them a response. We want them to know that they actually successfully sent it. We can send back the my story object to them. And bam, we have created a method to create stories. And so if I save this and I go again back to our newsfeed, and I'm going to refresh this. Hopefully, if all goes well, HackerMan will be in. So we should be able to hit submit, and ta-da, HackerMan is in. But no, we don't quite have comments working yet, so yeet cannot be appended to the end there. So now, if I'll give a very brief period, but I would definitely like it if you guys could try and figure out how creating comments would work. It's again, just like with the get comments request, it follows very similarly to the post request of comments. I think there's literally a 1 line difference apart from changing everything from stories to comment. So I'm gonna give 3 minutes there. I hope that's enough time, but we are cutting things just a tad bit close, and I do enjoy you guys eating food. I do enjoy you guys being moderately healthy. Hopefully just a tad more healthy than I am. So we'll try and let things go. But help queue is always open because it's running on a server. Haha. So I'll sit here and shut up for 2 minutes. All right, I hope you enjoyed your peace and serenity. It is now I guess in your Eastern time, folks, 2:30. So we're gonna give you the spoiler alert. Yeah, pretty much the only major difference is now you get to add the parent, which was passed along with the request yesterday. So I'm gonna try and speed run this a little bit. So we'll have a router.post to the exact same route that we had earlier. This is where the difference between endpoints and routes comes in, is that the post endpoint of the comment route comes in. So we'll have that. We'll have const. Do I call it my comment, new comment? We are very consistent people here at web.lab staff. So the ID, as before, if I can type, will be data.comments.length. So, and then we will creator name there will be my name, and then parent we said was coming from rec dot in this case it comes from body.parent, and then we have the content which comes from rec.body.content blah. And so there we created our comment, but now we have to again push that to our array to keep it a running tab, and then we send that new comment back to them so that we know that they got it and everything's all good. So now, hopefully, if we save this, we go in here and we open our local host again. I'm going to refresh. It's going to get rid of my I'm in. So I'm going to add I'm in again. And we don't have enter that automatically sends it, blah. And we're just going to add yeet to the bottom of that. And whoop-de-doo. Basset hounds are better. And you can't do anything about it because this, for now, just exists with me and me alone. Yeah, and I don't think we have just a whole lot left, so your food will not be too far away. So we already did that test. So what comes up next is you might notice that if we refresh, everything just goes away. This is because that data variable gets reinstantiated every single time we start the server with a refresh. So what Johan will cover after lunch is databases, which will be a persistent way of storing our data, and that whole hard-coded data mess will be absolutely useless. Now, one extra side little note before we let you guys go is you need to get MongoDB actually set up. You should have done that last night, but if you didn't, you got like 20 minutes. You better speed run that. You better have fun. Come on, get to it. Does the other staff have something to shout at me for? Any day now. I'm leaning towards no. All right. Well, in that case, somebody can take over this and start
Sorry,
streaming music.
something to shout at.
Okay.
Make sure that if you haven't created a MongoDB Atlas account, you follow the instructions that are on Piazza.
All right. Well, somebody can start streaming music in my stead because nobody's going to like it when I start streaming music, as it's both metal and copyrighted. I will stop sharing.
Okay, we're gonna go ahead and get started. I'll be talking about intro to databases before Johan dives into the workshop with you guys. So let's get started. You remember in our previous workshop with Noah and so we have this local variable called data that stores all our stories. But you remember whenever you modified your code and you would it would restart the server and you would kind of lose everything, and you'd have to keep replaying, like keep posting new stories and comments just to see it. But there's like a lot of other stories. I mean, a lot of other problems we have, because like, what if you close terminal, or like your server crashes because it's hosted on your laptop right now, or like your laptop runs out of battery, like all your data is gone. There's a lot of reasons why we don't want to store our data just locally on our computer. And the answer to that was going to be databases. I'm going to go over a couple approaches in this intro lecture to see why we should use a database and what way we can use it to best store all of our stories and stuff in Catbook. So you all should have done the MongoDB setup. It only takes like 5 minutes. You haven't, just do that now. But yeah, so, oh, I didn't go. Another thing that database helps us handle is like if you have a lot of data. So first of all, if you're storing all your data locally still in this variable, you got thousands of users and they make a ton of stories and comments, it's popping off. Your computer will run out of memory and you will be very sad. So this is not the best. Like, we need to also store them permanently. As I said, every time you modify your server code, and it would refresh and you would lose everything. So one approach that still isn't the best, but I'll go over just to demonstrate what we're looking for in a database, is using something called data.txt. What if we stored all our stories and comments in a handy dandy file called data.txt, stored it on our hard disk, like, so that would store everything permanently, persistently. It would work throughout your server refreshes. But do not actually use this approach because you will not pass web.lab. This is more for demonstration purposes. I'll show you guys some code snippets. So let's say we're using this data.txt approach, which is a little better than storing things in a local variable, but we're not quite at the level we want yet. Let's say we're doing this. We read the data from the file in this little function here. We parse it, and then when we save data to it, we write the data to the file. You don't have to really understand what these functions are doing inside. Just think black box them in your head for now. But for example, let's say we post a new story. We push it to our variable data.stories.push. And then we write all of that data to our file data.txt. And then we load any new stories from our data.txt file by using the read data from file function. So let me show you guys why this can be bad and how it works. So right now I'm running a version of Catbook. You don't need to follow along on your code for this. I'm just going to show you guys. But in the code here, we have, my bad. Okay, so you can see the functions I was talking about: read data from file, write data from file. And then we read it here, blah, 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 blah. I'm going to post something on Catbook. There's already something here. Hello. This is a comment. Okay. So.
Hey, Shan, can you zoom in on your code?
Oh, yeah. Okay. Cool. So right now, if I refresh the page, if I restart my server, which I'll show you right now, I'm going to Control-C to set my server. I'm going to restart it. And you'll see if I refresh the page, all my stories are still there because I use this cursed data.txt approach, which we can see right here. This is data.txt. It's not very pretty, but it did store everything I want. It satisfied some of the requirements I was looking for to store my data persistently. But you can imagine what happens if this file gets really, really huge. And there's a lot of other cursed things about it that I won't go into, but this demonstrates my point. So let's go back to this. Cool. So data.txt, basically, we have saved every story or comment whenever someone posts. Because of that read and the save function, it saves every single story again, even ones that are already in the data.txt file. Very bad. This is not optimal. Also, for memory usage, it still keeps all your stories in RAM. It does persist it, but still, if you get a lot of stories, you're kind of screwed. And also query speed. This is very important. So to find a story with any particular ID, we're doing a linear search of the stories too. We have to do that to get it. We don't really sort this by any means. We kind of just throw in data.txt, and yeah. We ideally want to find and query for documents fast because we want to return them to the user fast. And another one, there's a single point of failure here. If your laptop hard drive breaks, runs out of battery, you throw your laptop out the window, yada, yada. And another thing that I want to bring up is concurrency issue. So if two users post at the exact same time, and we're all trying to write to data.txt stored locally on your machine, it will break somehow. User A might overwrite user B's, user B might overwrite user A, but bad things will happen. And it is very unsafe to use this fs.write multiple times on the same file without waiting for a callback. And you can imagine if we're waiting for the callback and line up every user, it's going to take a long time for anyone to save a new story or post. So we don't want to do that. These issues have all been solved for us by using databases. So you might have heard of some of these. So like MySQL, PostgreSQL, SQLite, MongoDB, which is what we'll be using in this class. A database is essentially an organized collection of data. And database management system is software that facilitates interactions with a database. Usually when people are talking about different databases, they're referring to actually the management systems, and they like to use the terms interchangeably, but I did want to point out the differences here. So to provide a visual example, let's say that our database here is this nice warehouse, lots of boxes, lots of stuff, and we have a nice database management system, this little penguin man here, and the user. So if he's reading from it, he'll be like, give me stories. And the penguin will be like, okay. And then we'll go to the database. And then he's going to wrap up all the things you want nicely, like exactly what you want, specific stories or whatever the user requested. And he's going to fly all the way back to the user and be like, here's the data. Hey, that's how you read from a database. And then so for writing to the database, they'll be like, put this new story in the database, or put this new comment in the database, or edit this story in the database, any of those things. The user will wrap it up in some sort of call, and then we'll go to the database, we'll put it in, and then we're happy. We can look at pseudocode for this. This will not work if you try to run it. This is just pseudocode. But basically, you can think of this database management system as the strings inside is basically the query, what you want. So this can be give me all stories, or only give me the story with a specific ID, or put this single story in the database, or delete any story posted by Aaron, or change the author of this specific story to me. Writes, reads, deletes, and updates are all different functions that a database management system can handle. So there are a lot of different databases out there. You might have heard of relational databases, which stores data kind of in tables. So it'll look kind of like this. SQL is a good example of this. And what we'll be using, though, is a document database. We're not going to be using SQL. This will store documents, which are JSON objects, which you've seen in previous lectures when we talked about the JSON objects. This is kind of like what the story looks like. And we're going to use MongoDB to do this. And you're already familiar with JSON because you went to all the workshops or you watched the recording. So MongoDB, which you should have done the setup for, this is just kind of their blurb, but TLDR is a document database, stores data in JSON-like objects. So the hierarchy of MongoDBs looks kind of like this. So we have our database, let's name it Catbook, and then we have different collections. These are for different types of documents. So a story is obviously a very different kind of document than a comment. So they're stored in separate places. So we have documents inside collections. And you can see here, these documents for comments, like our comment object has a parent ID, which differentiates a little from story, and well, yada, yada, yada. So we're going to replace data.txt, burn it to the ground. You're never going to see this again. Do not use this approach. You will not pass web.lab. Someone actually did try to use this approach last year. So we're trying to emphasize you should use MongoDB or some other database. You just have to approve that with us. But yeah, now we're happy. But there's still some issues we need to solve. So we've optimized our write speed because we're using a database management system. They do all that for us. Memory usage is optimized. Query speed is optimized. And concurrency issues are solved. But if you're like hosting an instance of MongoDB on your laptop, your hard drive could still break. So this is why we had you made an Atlas account, because MongoDB will be run somewhere else on the quote cloud. This will make your life a lot easier because you're not going to be running or hosting the database on your laptop. It's managed for you. And most importantly, you can share the data with your teammates. This is kind of how we had you talk to our API in the past few days. You'll notice you saw everyone else's posts as well. And yeah, so this is a lot more reliable than your laptop SSD because behind the scenes, they'll replicate your data, shard it for you, do all that good stuff that I won't get into. So our Catbook configuration without Atlas would look something like this. Your server would talk to a MongoDB that's hosted on your hard disk. However, if it's over the network, that means making it a lot safer, it's replicated, share your data with teammates, all those other points I need. It'll look something like that over the cloud. So once you're sharing your data with teammates, that means your teammate's server and your server can all talk to the same database, as long as you guys have the same like SRV string that you guys copied. And you'll never lose data. So basically a replica set is when they copy your data to multiple machines. So that ensures if one set is broken or it's got deleted or something happens, we'll just replace it with one of the other instances. I'm not actually going to demo this for the sake of time. You can see this in Johan's workshop. But yeah, so right now we've written a lot of API requests that will do something with our data. So in this case, we have a GET request that gets us all the stories. The user sends it over, the server processes it, and basically what your server should do is ask MongoDB, hey, get me all the stories. And then the DB will send it back. And then your server should respond to the client with the stories. And then the client will the front end code basically make it look all nice and present it to the client. That's kind of the flow here. But yeah, so the main takeaways from this is that you need to save stories and comments permanently. This is one of our requirements for like milestone 2, the MVP, and the final project. You need to use some kind of database. And you need a smart solution, and database happens to handle all of this. And last of all, if you're having troubles using MongoDB or setting it up, you should contact your staff. But usually once you have the SRV string and you replace the little carets in there with your actual username and password, not from the MongoDB instance, but from the user you made on the account, you should be good to go. But yeah, I'll hand it off to you.
Thank you, Shannon. Give me one sec. All right. So today I'll be talking a little bit more about MongoDB and how it works, and talk a little bit more about how to actually organize your data. So like Shannon said, MongoDB is a database system. It is a NoSQL JSON-like database system. So when you code in JavaScript, you normally hold your data in objects, and almost all programming languages have something like this. So it's just an object with field and some values. And this is a very natural way to think about data. And unlike SQL systems that force you to convert your structure into rows and columns or some other kind of thing, MongoDB just lets you keep all your logic the same, just keep using objects and just act as if the objects are just normal, are just stored as is. So you want to use MongoDB when you don't have like a schema really defined early on. So you don't have to overwrite a lot of your code with like changes and stuff like that. You can just change the one place in your code. If you make a lot of writes to your database, so for example, in Catbook, you're going to be getting a lot of stories. MongoDB is very optimized to read writes, to perform writes. So it was especially good in like Facebook posts, adding comments, or posting new data. So when you make an Atlas account, or when you start a MongoDB instance, you can think of this as like a warehouse that will store data about all your applications or anything that you want to put inside. And this warehouse has rooms or containers, just rooms or like a specific instances of like databases. So you want to have a database for every single project that you have. So Catbook has a specific Catbook database. And inside this database, there are boxes or collections. So MongoDB is a really organized machine. Inside every single like storage unit or database, it has smaller boxes, and these are collections. And everything inside is just a collection. And inside these collections, there's something called the document. So when you open the box, there's a bunch of items. All the items are of the same type. So because you're a really organized person like me, inside every single container, you only have screws, or you only have hammers, or you only have whatever. And this is how you maintain your data nice and neat. And MongoDB stores data inside something called collections, or a box. Inside this box, there's something called a document. A document is the object that you're trying to store, in a way. So comments have their own document, stories have their own document. And inside the document, every single document has field and values. So for example, a screw will have a length, thread, the type of screw head, whatever else you want to store about screws. So to reiterate, a MongoDB instance is the whole MongoDB program, or the whole cluster that Atlas is allocating for you. A database is a part of the instance that will store data about your whole program. Inside the database, there's collections. These collections store a bunch of documents, and all the documents should be of the same type. So screws, hammers, or like stories, comments. Every single collection will have just one type, but a bunch of them. Every single document is analogous to an object, and it has a bunch of fields and values. And this is more of a high-level review. So there's a storage facility with a bunch of storage units that has a bunch of boxes inside, and each box has one specific thing. Each box has a bunch of a specific type of thing, so shirts, screws, bucks, etc. And every single one of them has fields and values, or information about the object. In MongoDB terminology, it's instance, database, collection, and document. I'll pause here for a little bit because I know I went a little bit fast. If there are any questions in the chat, or just shout them out. Okay. So that's how MongoDB is structured, but we're not going to be directly interacting with the MongoDB API. We're going to use something called Mongoose. And Mongoose allows you to talk to MongoDB in a very nice way. Mongoose is a library that you can install. You do npm install Mongoose. And it's something called an object document mapping library. There's a bunch of different libraries that are built on top of database systems, like TypeORM or Mongoose. It essentially allows you to create an instance of a class, or it allows you to create an instance of a document that has much nicer methods. So instead of like making a post request to MongoDB every single time that you want to add data to the database, you can just do something like .save or .load or something like that. It is basically a wrapper around the MongoDB API. So Mongoose does a lot of things for you aside from just representing documents. It connects to the cluster automatically for you. It will create the document, track changes, delete documents. It can do whatever you want to do with MongoDB, but just in a very nice way. So aside from from just being nice to use, Mongoose also has one very important thing. Before that, does anyone have this drawer in your home where you just put everything because you just don't want to organize it or deal with it? It kind of looks like this, or like this, or maybe even like this. Have you ever tried to find anything? I'm very prone to losing stuff, and I think I've lost like 4 phones to like this drawer, or like 7 USB cables, and I always have to buy a new one. And this is how things get lost. And data is the same way. I did actually buy 4 phones. When I was in high school, I like jailbroke phones, and I used to like break them a lot. And like my parents got really mad at me, but it'd be like that. Yeah, so you can never find anything in this kind of drawer because it's very disorganized. And the same way, MongoDB could become very disorganized. It doesn't actually MongoDB doesn't actually enforce any of its rules. It's like a very lenient parent. It tells you what to do, but it doesn't actually ever check that you did it right. So if you have like a box that has like stories, or sorry, a collection that has stories, you can add comments to that same collection. It won't actually stop you. So the reason that this is really bad is because when you start your project, you have a clean instance and you become really good. You have like a lot of like organization, and you always make sure that you always only add comments to the comments collection. But over time, it gets really hard to keep track of, and just running code once that doesn't have the right data will add a new object to the collection that shouldn't be there. And over time, as you keep making changes and changes and changes, a collection could become really disorganized. And it will have one of everything. And at that point, it becomes basically useless, because you'll query the comments collection, but you will get a story back. And your code will not know how to deal with this. And you're either going to have to do a lot of like checking and a lot of conversions, or your code will just simply break. So to fix this, there's something called a schema. A schema is a computer science term used in many programming languages and database systems. So what a schema is merely a description of what the object should be. So schemas allow you to define, for example, the name of the field and what type the field should be. Again, the type is things like strings, numbers, arrays, booleans, whatever you want the type to be. So for example, right here, I have a new schema where I stored my name, my age, and then the pets that I have as an array. So if I add this to MongoDB, and one time I used instead of doing an array, I just add a string for pets, MongoDB will not stop me, and it will add it. And whenever I try to query the data, and I act as if pets is an array, but in reality I put a string, my code will break, or it will do some really weird things. JavaScript is really weird to like, it's really hard to break because it allows you to do many things. But if you want your code to be correct, you want to make sure that the data is always clean. So Mongoose allows you to implement schemas, which are just a description of the type of object you will store inside. And each collection should have a schema when it's created, and it will enforce it whenever you make a change or whenever you're trying to add something. So in the previous example, if I try to add a new document to the database where my name, the pets field, where the pets field was a string instead of an array, and I hit like save or something, it will actually not let me and tell me the pets field is mistype, please fix pets field. And that's how I'll know my code is not correct. Okay, so there's many other types aside from the ones that I showed here. This is a very oversimplified way to explain how Mongoose and MongoDB works. In reality, there's a bunch of types and a bunch of like switches and knobs that you could like turn to really like make a very complex database that we won't cover. But most of the time, you're just going to define what type and what name the field should have. So now that we know what schemas are, now we're going to move on into something called models. So note that schema is just a description of the type of object that should be there. It's just fields, the name of the field, and the type that that field should have. And it's not actually it's just this one feature of the collection. The way to think of it is that many types of objects have the same schema. So for example, many comments and like, I don't know, retweets have the same structure, and they will have like the same schema, but they're in reality different things in your head. And that's what models are for. Models take in a schema and allow you to construct documents and like get documents from the collection, post new documents. In a way, when you create a model, you're essentially creating a collection in your database. Does that make sense? I'm gonna stop for like 10 seconds. Yeah, so the main difference between something like SQL and something like MongoDB is that you can change your schemas pretty easily. All you have to do is go back to the file that you defined the schema in, add whatever changes you want to do, and Mongoose will automatically update your collection. Cool. So now I'll go into actual code and tell you guys how it works. So the first step to creating a collection is to define the schema. So if I want to add users to my database, I'll create a user schema. And Mongoose just has a schema class, and I'll create a new instance of it. Now that I define the schema, I want to create a model. And the model will take in the name of the collection that you want to put. So in this case, user, and the schema that you want this collection to follow. And you can use Mongoose as a model for this. And the user variable right now represents the whole collection. Cool. So if you want to add a document to your collection, you will take the model, create a new instance of the class that the model has, and this will represent a document in the collection. And you use the new keyword for this, and you will initialize it with the data that you want the document to have in the constructor. And again, you will just have to do very simple methods like .safe, and which returns a promise and writes the document to the database. And right here, if I do tim.safe, it will talk to MongoDB, add it to my collection. If the collection does not exist, it will create the collection for you, which is one of the key things that make it really easy to use. And after that is complete and it's successful, it will return whatever it wrote to the database, which should be the same, an object that follows the same schema. And then you can return it to the front end or do something fancier with it, whatever you want to do. So altogether, this is all the code that you need to actually set up a database. We wrote like half the code for you, but just to talk about how everything works. So in server.js, you don't have to open it. You'll see it in a bit. We just have to import the Mongoose library, paste in the string that we got from Atlas. Right here, the user is called user and the password is called password. This is fake, of course, but you will replace these two things right here with your actual username and password. Database name, sometimes it's included in the string, sometimes not. You don't really have to worry about options. These are just details that we abstract away, and they're not too relevant. They're a little bit more advanced. So after you define all the fields, you do mongoose.connect, and this will take your SRV string and then figure out which instance of MongoDB it should talk to. And afterwards, it will return a promise that says, and you can say something like connected, or if it failed for some reason. Typically, it fails if the username and password are wrong. It will tell you why it failed. After you connect, you can now create new schemas and new documents. So right here, I create a new user schema. Then I create a model with it. And then I create a new document using new and the name of the model or the instance of the model. And then you hit that save and add it to a collection in the database. So this is kind of like an end-to-end example of everything. Is there anything unclear so far? Because you guys are going to get to implement it in the next couple of steps. Again, there's the questions doc if you guys want to like ask for more details about databases and stuff, and we'll be happy to answer. Oh, okay. Model versus schema. So a schema just defines the data type or like the document. A model is actually a instance of a collection, or it represents an instance of a collection. So you create a model using a schema and you give it a name. And when you create the model, it will actually go to MongoDB and create a new collection for you. While a schema is just one of the things that the model needs to figure out how to make the collection. What do you need? User. The first parameter over here inside model, the reason that we need user in quotes is because user is just the name of the collection. Mongoose lets you, or it requires you to choose a name for the collection that you want, and it will automatically create a collection for you. And yes, you can have user models. Okay, so after you run this code over here and you hit that save, if it works correctly, you can go to Atlas, and Mongoose did a bunch of things for you already. It created a database called test. However, the database had already been created for you. If it wasn't there, it would create it for you. Then it created a collection called users. Note that I put user in capital letter and just in singular, and it somehow made it into a plural lowercase form. Mongoose does this for you, and it's just because semantically it's easier to think about collections as being a bunch of something. So a better name for it is users versus just user. And if we open up the collection, there's the pets, the name, and the age. You don't have to worry about __v. That's just the version of the model that you have. It's just something that Mongoose needs to work. And it created something else. It created something called an ID. So before we actually had to create the ID, we did like ID is equal to 0 or ID is equal to 1, but you don't need to do that. So MongoDB uses this concept of an object ID. An object ID is a string that represents a unique identifier for that document. The ID field is huge, and it's very unlikely that you will ever have two documents that have the same ID. It's like 1 in a trillion chance of having a collision. And that's just because of the way that an object ID is made. It's always assigned as _ID. If you go to MongoDB, you can tweak some things and change what you use as the identifier. But for the most part, you want to stick to the one that's automatically generated for you. And the reason that we need an ID, aside from identifying, is because it allows you to describe relationships between documents. So for example, in the comments collection, we want to have like a document that contains a parent ID that represents the ID of the story that this comment should have. And this is how you represent relationships, even though the documents are just, there's no like hard and fast, there's no like direct relationship in the code, but if you use IDs and you link IDs to each other, that's how you define relationships. Okay, so that's created documents and connecting to the database. Now I'm going to go into actually finding and deleting data from your database. So Mongoose has a method called find. This method takes in an object where you can put fields and values, and it will return any document in the collection that has the same fields and values. So for instance, right here, I do user.find and an empty object. The empty object has no fields and values. So it means that it will return all the documents that exist in the database because there's no like requirements as to which document we exactly want. It's called a query, and there's a MongoDB query language that you could look up online, and it can do very fancy stuff like finding documents that like have some geographic relationship to each other. There's a bunch of things MongoDB offers, but for the most part, you're going to want to do just find and the fields and values that the object should have. So how this looks like is, for example, if I want to have all the users named Tim, I could just put name colon Tim, and it will return all the users named Tim. If I want to add more fields, I could do Tim and the age, and it will return all the users that fulfill both of those, that have both of those fields. Cool. To delete document, you want to use delete one and the type and the fields and values that the document that you want to delete has. Normally, you will use the ID to make sure that you're deleting the correct document, because MongoDB makes no assertions or no promises as to which document it will delete. It will just delete whichever one has names equal to Tim or whichever one fulfills the query that you put inside the method. There's a very dangerous method called delete many. Delete many deletes all documents that match the query. You want to be really careful with this one. If you're using delete many, you probably should not be using delete many. There's very specific cases that you want to use delete many, like when a story, let's say when a story gets deleted and you want to delete all the comments of the story, maybe that's a correct usage. But be really careful with this because it will actually delete the whole data, delete a bunch of documents, and getting them back is really hard, and I don't think you can if you're using a free MongoDB instance. I once deleted a bunch of like documents from a year up because I used delete many instead of delete one. So be real careful with this one. Okay, so far we've seen a bunch of Mongoose code. And the way that the Mongoose is set up in our server is that we have a file called api.js, which handles queries. It will take the user model and fulfill those queries using the user model or whatever model you want to use. And the user model takes in a schema, and it has a couple more methods to interact with the collection. And whenever you're using methods like find, delete, or like save, it will talk to MongoDB in the background for you, and it will return a promise. There's many other parameters that you can use, like in Mongoose, and validation and much other things that are very like useful. And you can look this up in this link. You have your own time. All right, so we'll actually be moving on to the workshop soon, so I'll stop here for questions. Yeah, so you don't want to delete documents by accident in an internship. I don't know if you'll get a return offer, but let's hope you do. So yeah, so the reason that I deleted everything from my year up is because I actually wasn't using Mongoose. I was just using the the vanilla MongoDB API, and there's a method called delete, and I thought it deleted just one, but no, it deletes everything. Don't do that. Okay, so for the workshop, we're going to do a couple things. We're going to create new schemas and new models, connect them with API.js, and then hook that to MongoDB so we can actually save all the stories and comments we have. So I created this nice little cheat sheet in web.lab.2/Mongo snippets. So you don't have to go back to the slides and figure out how to create and delete documents. I will just keep this handy when I let you guys on your own to implement something. Okay, so the first step is actually connecting MongoDB and Mongoose. So I'll have you guys do a git fetch, a git reset hard, and check out to workshop 6 starter. I'll give you guys like 20 seconds. Okay. Cool. So now you want to take out the Mongo SRV that you guys hopefully already have from the setup guide. It will look kind of like this. It says Mongo plus SRV. And right here, there's 2 things, the username and the password. And you want to replace these things right here with your actual username and password. MongoDB doesn't know them because if they know the password, there's some really weird security happening in the background. You don't want this. Okay. So you take that SRV and you want to go into server.js. And there's a variable called Mongo connection URL. And you want to replace this with your SRV. Right now, I think it's an empty string. So I'll do this with you guys. So you want to go into server.js. Right here, it's an empty string. You want to, one sec. I'm going to go here, paste that, save it, and you want to do npm start. And it will say something like connected to MongoDB. If you need help setting up MongoDB or don't know where your SRV string is, go to the help queue and someone from staff will help you. Can you guys do like, I don't know, a thumbs up reaction or some reaction in the chat when you guys have this working? I'll give you guys like another 30 seconds. The DB name part is the name of the database that you created. Yeah. So you want to go to like cloud.mongodb. The SRV is already in the public Git cat bug. I don't think we have to like censor it. Yeah, you never want to share your SRV. Normally, you will put this inside something called an env file, which is a file you only have locally that contains all your credentials and all stuff that should not be public. you do not want to commit this file to GitHub because the GitHubs we set up for you are public. So anyone that opens your GitHub and has your SRV will be able to do anything with your database, essentially. Okay, so you should hit clear, create new cluster. Once you create a cluster, you want to do connect with your application. It will give you something like this. You want to copy it, and you want to replace the fields over here. DB with the database name. In this case, it's Black Swan. And then the username and password are set up here. So for example, this is the database for Buka Buka. Oh, yeah. This is the database for Buka Buka, and I have a user called Buka Buka. And the password I set up like when I created the user. And MongoDB has no idea what it is. So I have to just remember that. And then once you have that string, you want to put it here in line 29 of server.js. The database should not have a space, I think. Correct me if I'm wrong. Does it work with a space? I don't
Wait,
think so.
click into Black Swan. Just click into it. And you click collections.
MongoDB is a little bit slow sometimes. The database name, I believe, is the same thing as the name of your cluster.
Yeah, so you have 3 databases in here: Buka Buka, Ignite, and Black Swan.
Yeah. As a fun fact, all the Buka Buka does is keep track of your question and its happiness. You guys have asked 330 questions today, which is kind of impressive. I'm really impressed by this. Okay, so the way that you figure out how it's working is if you do npm start and you receive the following message. If this does not work, or like you put the wrong thing, if you do npm start, it will just give you unable to parse string or something like wrong username and password, some error message. Okay, again, if you need help, go to the queue and you guys can go to the breakout rooms and someone will help you set this up. Okay, so I'll be moving on to one sec. Okay, I'll be moving on to the next slide. Again, it should look something like this. I don't think this one works anymore. So now we're gonna actually create models and schemas. And we wanna create models and schemas for comments and stories because those are the 2 things we wanna store in our database. So in Shannon's lecture, you guys saw this diagram. And we're gonna have a database for a cat book, 2 collections, one for stories and one for comments. And each of these collections will have a bunch of documents. And each document will have the fields and values of the comments and stories respectively. So if you open the models directory and open story.js, this is where we're going to create the model for stories. And the story will have 3 things: the creator ID, the creator name, and the content. And we want each of these to have type string. And like we said before, the way to ensure that every single document in the collection follows this schema is by defining a new schema. So I'll actually do this for you. So if we go to models, we'll have an empty file right here. And to define it, we want to import mongoose. I'll just do this with you. You guys don't have to follow. You guys can follow along, but you guys will check out to the next step where this is already defined for you. in this workshop, I will do basically anything related to stories, and you guys will implement the comments part. So you want to import Mongoose. And afterwards, let's say I'm going to create a story schema. And you want to do let's see, what did we need? We needed the creator name. We needed the creator ID. And we wanted the actual content. String. Okay. So once we have the schema, we want to create the model. Schema. Okay. And release it to my. Actually, now this is backend. Okay. So as you can see, like Mongoose code or like Mongoose is actually not too complex to actually use. It's pretty straightforward. You just create a schema, then you create a model, and then now that this will actually create a collection for you. So again, what we did was create a new schema, and we created a model with it. Okay, so I'll let you guys try to create a comment model for 5 minutes or so, or 3 minutes. It will look very similar to how I created the stories. And you want to do it in the comments file in the stories folder. And all the fields are here, and they all should be of type string. Yeah, I can go back to the code. So this is the story code. Actually, we don't need creator ID. We just need creator name. Creator ID will be a better way of identifying who created it, but we could also just use creator name. Yeah, one field in the comments model, or sorry, in the comments schema, will be parent. You could also do parent ID. We just to make it look a little bit nicer, we use parent. But what it will store is the ID of the parent, of the parent story that it comes from. No, actually, there's half of this here and half of this here. Let's see how complicated this thing. Okay. If you're done, you could just do like, I don't know, some kind of reaction or something. Okay, I see like maybe 50% of people are done. We'll give you guys another 2-3 minutes. Again, there's always the help queue and the question stock. Oh, again, just to emphasize again, if you go to web.lab.2/Mongo snippets, there's a cheat sheet where you can read about all the things you can do with Mongoose and reference code that you'll probably need to be writing. I'll start writing some of the code for this code for comments. So again, we want to import Mongoose. And then we want to do the comment schema. And here you put the fields that you want. And I'm going to do that. I'm going to do something like this. Parent is a string because it represents an ID. An ID we used as a number in the previous workshops, but MongoDB actually doesn't use numbers for IDs. MongoDB uses something called an object ID. An object ID is an ID that has a very specific structure. And having an ID that has a very specific structure lets the people at MongoDB do very fancy things, which makes retrieval way faster than just using numbers. And in reality, we should actually not use string. We should use something like Mongoose that types that object ID. But an object ID also can be a string. So just for simplicity, you can write it as a string. Let me check the help queue. Okay, it looks like everyone in the help queue is being helped, so I'll move on to the next step. So your model should look something like this. 3 fields: creator name, parent content, all string. The parent is the ID of the parent story, and that's how we represent the relationships. And then we create a model with a schema and export it. Okay, so now that we have the model set up, we want to actually connect our API And instead of just using a variable that we hard-coded in the last 2 workshops, we want to actually talk to MongoDB. So you're going to have to do git reset hard, git checkout workshop step 1. And again, you want to go to server.js, line 20, I think it's 21 or 27, and take the SRV that you had in the previous step and put it there. I'll give you guys like 20 seconds to do this. Cool. You want to go and take the SRV that you had before. I forgot to delete it. If you're stuck and you really can't get MongoDB working, here's the one we use in Catbook. Cool. Yeah. Okay. So what we want to do in this step is import the models from the models file that we created, and then use it in our API. So within api.js, if you open it, you're going to see a line called something like this. We use require in the backend to import things from other files, unlike in the front end, where we have a little bit of a different syntax. And you want to, and what this line does is it takes the model that I exported in the story file. So if we open story.js, this was the export, and it imports it into api.js. So if you open api.js, you'll have a line like this. And so if you want to import the comment model, we will do something like same thing, basically. I'll let you guys 10 seconds or so to like import the comment, but it should look something like this. Okay. So now we're going to be migrating the endpoints that we created in the previous workshops and use them and connect MongoDB to them. That way we actually write to the database. So right now we're going to implement get stories. So to implement get stories, what we did before was go into a variable and then look up all the stories and just return all the objects inside that array. In MongoDB, it'll be slightly different. We don't want to just return, we want to actually make a query to the database. And the way that we do this is by using the find method, which is defined in the cheat sheet somewhere. Again, we want to use the find method that's over here. So the find method is the model is the first argument, then that find the query you want to do, and it will return a promise that has that will return all the documents that match the query. So we already have the comment model already imported, and to get all the stories, we will just use something like find an empty query. So the reason that we need an empty query again is you want to get every single one of them. If I want to, for example, return only stories that have the word hello in their content, or that have maybe all the stories that are created by me, we'll do something like this. But right now, we just want to return all the stories. So we do empty.done. Again, a promise is something that runs after some async code. or something that like gets called whenever some async code is finished running. And it will return an array containing documents. And we just want to send that back to the server. So the code will look kind of like this. I'll give you guys like 10 seconds to copy the code, or 10 to 20 seconds. Here in the slides. Okay. So now we want to write the post endpoint. So in post, we created a new story based on the parameters that we got from the front end. So a little bit of a side note here. This has been emphasized in a couple of previous workshops, but just to reiterate again, GET requests and POST requests store data in different places. In the GET request, rec.query contains all the data that the front end sent, so all the parameters. So if you want to, however, in the POST request, everything gets stored in the body field inside the request. So for example, if you wanted to access the content field that got sent by the front end in a GET request, you will do rec.query.content. If you want to get it from a POST request, though, it's rec.body.content. And okay, so I'll implement the POST request for stories, and you guys will implement the POST and GET request for comments in the next step. But for now, so right now we actually have no idea what the creator name is because the front end is not sending it. So we just want to hard code it for now. So we want to do something like my name is equal to and so the way that you create a new document in a database is by doing the new operator, by using new and the name of the model that you're creating. So is equal to new story. And let's see, what did story need? So story needed two fields, creator name and content. So creator name body. Oh wait, so creator, we don't have a creator name right now, so we'll just hard code it. Body. After we create the document, we want to tell our database to save this. So do that save and do that done. And the promise will return the document that you created. And we just want to send that back to our front end. We use that send start. Okay, I'll check the chat to see if there are any questions so far. Okay. So note how one design thing that we want to make sure right here is that we only ever want to return when we know that the operation worked. So some very bad practice will be to do something like return send the story and before we actually save it. If we do this, Express will respond to the request and then it'll save. However, if save fails for some reason, the front end will never know because it already got a 200 status code back and it thinks it worked. So when writing code, be sure that you only send back to the front end whenever you're sure that the operation was correct. So that's why we need the save operation to happen before the send, before we return anything to the server. So post story kind of looks like this, like the code I just showed. You can check out to step 2. Again, maintain the SRV that you kept in the previous step. You don't ever want to commit to GitHub, and go back to server.js and replace the line with your actual SRV. Cool. All right, so now we'll implement the get request for comments. This one will be on your own. So you can hop into the help queue if you need help about how to implement this, or reference the cheat sheet that's at web.lab.2/mongo-snippets. It will look kind of like this. And you could also find this cheat sheet if you go to weblab.mit.edu/resources, and there's a cheat sheet subsection inside that page. So you want to, for this step, we're going to implement the get comment endpoint. Again, what we want to do right here is not return all the comments, but just return the comments about a specific story. So you're going to need to know the parent. And the front end sends the parent in rec.query. So you will probably have to use this. And most of the code is already written for you. It's right here. Note that right here, it will not be an empty query, because an empty query will return all the comments. And we want to return just the comments that are relevant to a specific story. OK, so I'll give you guys like 3-5 minutes or something. Check the question stock, see how it's doing. Yes, you can use any variable instead of students right here. What the fuck? My computer crashed.
Oh, did we lose Johan? Oh, he's back.
Nah, we're back. 1 second though. Let me know when you can see your screen, my screen.
And we're good.
Cool. Yeah, so you can use any variable right here as the name. It's good coding practice to have variable names that make sense. If you write something like this and then return this, code will work, but whoever tries to change this code will be really confused. Generally, try to make sure that the names make sense. Okay, I'll be moving on a little bit. Again, go into the help queue or ask questions in the questions doc if you need help. Cool. So right here, we don't want to do an empty query. We want to query only specific documents. So again, if we go into the comment model and the comment schema, we can see the comments have a field called parent, and the parent represents the ID of the story that this comment should be below. So if we do parents equal to rec.query.parent, it will return only the comments that have the parent field set to the ID of the story that this belongs to. Again, we use query because it's a GET request, not a POST request, and all the data that we put inside the request is stored in the query. Cool. And the solution should look kind of like this. Okay, so after we implement the GET request, we also want to implement the POST request. The POST request will look very similar to the POST request we had for stories, but just that it will have different fields. And again, so we want to implement a POST request for a comment. We want to extract the ID of the story that it comes from, put the creator name of the comment, and the content of the comment. Those are the three fields that we want to store. So I'll give you guys a little bit more time to implement this one. Just use the how implemented new story as a guide to implement the other post endpoint. Rec is a variable name we use that represents the whole data the front end sent. Traditionally, it's always called rec. It stands for request, and this is where you're going to retrieve all data that the request has, essentially. I like how I don't use them. I just use book as a questions doc. I should probably actually check the questions doc. The creator name should also be hard-coded, by the way, because right now we don't actually have the name of the user that made the request. We'll implement names and authentication on Monday, and we'll do fancier stuff like actually display your name in the front end, stuff like that. right now there's not. If you want to actually check that your database is working, you could just do npm start. And right now I haven't implemented comments, so only stories will work. And you can go into 2000. We'll have cat book. You can say something like hi. I don't know, what is this madness? Did I typo something? What the? Comment does not define I. Yeah, JavaScript lets you like run code without it actually being valid code, which I find really annoying. Next week, you're going to learn something called TypeScript, and which prevents errors like this from happening. It's much, much nicer than JavaScript. I love it. Right now, this semester, next semester, they're teaching 6031 using TypeScript. So I would recommend that one instead of just Java. It's a great time. Did I forget npm install? Cannot find modules slash comments. It's weird. Oh. Yep. And right here, Bambit Ditto appears because that's my name in line 50. Okay, so I'll walk a little bit through the code. Let me just check the chat first. Dude, Java, it should be npm start. And also Java is much worse than TypeScript. TypeScript's much nicer, much nicer. And generally, yes, MongoDB is specialized to handle data. You could run a MongoDB instance inside Heroku, but that is cursed. Do not try it because Heroku is not meant to be a database, or it is not like optimized to be a MongoDB instance. And it will probably crash if you get many users. So I will just avoid using servers for things that they were not meant for. Let's see. So we want to create a new comment, and the new comment will use the data from the front end. So, and the creator name. The creator name comes from, it's hard-coded for now. Parent is stored in rec.body.parent. And the content is stored in rec.body.content. So just a little advice. Most of the time when you are writing code for your web app, many bugs will come from the server not being able to load data from the backend or the front end not sending the correct data. You want to make sure to have really good documentation. And I know that body.parent is not undefined, or that the front end actually fills something in this field. However, vanilla JavaScript will not actually enforce this. So if I did something like write that parent that parent underscore name, it will run. This will be undefined, and either I believe Mongoose will let it slide, because undefined is just a string that has not been initialized. But you will get weird bugs. So either put it as a comment or make a Google Doc that you define all the endpoints, that way you make sure that the correct data is being sent. Again, TypeScript does this for you. TypeScript next week. We want to save it. This actually saves it to the database. And then it will return the comment that it saved. And then you want to send it back to the front end. Okay, and this is kind of how it will look. Actually, fun question for the class. What will happen if I do something like this? Will it run? Will it save? Will it fail to save? Will it save 3 to the database? Or will it just throw some weird runtime error? Actually, let's find out. Let's see. So if you go, actually, let me do it for stories, since I know that stories worked. So it saved it. It didn't throw any errors here. And it also didn't throw any errors in the front end. But what actually happened was that when I created the story, yeah, it returns something. This seems like an error, an unrelated error. I'll ignore it. But if we look at what it saved, it actually saved See, so this is what Mongoose guarantees. It guarantees that even if your code got messed up and you wrote a variable that shouldn't have been there inside when you initialize the document, the database stays consistent. So even though I added outputs as inside the constructor, Mongoose knows that the schema does not allow for outputs. So it will not actually commit it to the database. And that way, even though your code might be right, might not follow the schema, the database will always follow the schema. And this will prevent your database from ever getting really screwed up. And if it gets really screwed up, you're gonna have to do some things you don't want, like going through the whole database and deleting any object that does not follow the schema, nuking the whole database, or just closing the project and never opening it again. So let's avoid that. So this is how post comment should look. And this is what I wrote over here, more or less. The creator name is hard-coded. Rect.body contains the parent and the content, so we initialize it that way. And new comment.save is a promise that returns the comment that was saved to MongoDB, and we want to send that back to the front end. So you want to do npm start, npm run hot loader. That way you can check if it works. And right now you should be able to post a story and post a comment about a story. And now even if you reload the page and restart your server, nothing will be lost. So let's see. Yes. Just line. Whatever, it's fine. So even though I restarted the server, once I reload it, all my testing data is still there. Again, it's very important for the SRV string not to be public. We make it public because we want to make sure that you guys have a working cat book on your end, even before you know what MongoDB is or before you know anything about how databases work. In an actual project, you will want to make this string a secret. A secret is a concept that is very like popular inside like things like GitHub and like DevOps kind of apps. So the way that you do a secret is that you make a file called .env. At that env file, you will write something like Mongo SRV, if I can type. And you want to copy this, cut it, go to the env file, type it here, save it. There's a file called .gitignore. .gitignore is a file that GitHub uses to know which files never to commit to GitHub. So right now in the gitignore file, we have client.dis bundle.js. This means that the code that gets compiled on your end. So this huge file right here that contains all the code for the front end never gets committed to GitHub because we don't want it. And it also says that you should never commit not modules. This is an error this is a mistake that everyone will do at one point, or that most people have done at some point. You commit a huge folder that has thousands and thousands of files, and this will like make your GitHub like very sad. So you want to add that to the gitignore, and you also want to add the .env file to the gitignore. If we go and do git status, check that the only file that it says that it will commit is the .gitignore file. It will not commit the .env file. If I remove this from here and do git status, it will commit the .env file, and we don't want that. So after you define the variable inside your env file, you want to go into server. You want to do there's a library called .env. Require .env. This is a library that loads all the environment variables and allows you to use them in your code. You process.env.mongo SRV. Let's start. It's color. You can stop that. Yeah, well, I wouldn't bother with this installing because it takes like a minute. But, oh, yeah, so the .gitignore file is a file that GitHub uses to know which files to never commit to GitHub, or in other words, ignore. You want to put it will take in the names of the files to ignore in every single new line. So right here, it's ignoring the bundle.js file, which gets made by Webpack, and the node modules file, which is the folder with all your dependencies, and the .env file. The .env file will store every single secret. A secret is something that you don't want people to know. So credentials, passwords, usernames, special config variables. This is used when you actually deploy your code. I think Deeson will cover this again. But things like the Mongo SRV, do not follow our example where we just put it in the code, because someone will be able to read this, will have access to your database, delete it, change the schema, do anything with it. So a .env file allows you to have some security that all the keys will never be public. And the way that you use a .env file is by using a library called .env, and then calling .config, and then using process.env.mongo.srv. Now if I do npm start, hopefully it won't fail. I'm gonna check the questions doc. Yeah, so it says connected to MongoDB, even though I actually never typed it. I just typed it in the end file. Again, if your code isn't working for some reason, you can check out to Workshop 6 Complete. This will have the SRV that we use for Catbook. You can replace it with your own. And actually, if you go to your Atlas account, you will see that you'll have a new collection here. And then and inside the collection, you'll have your stories. Let me make this bigger for you guys. Yeah. So if you go to Atlas, it will look something kind of like this. M files are not included in the cheat sheet, I believe. Yeah. Yeah. So if you go to the your database instance, or sorry, your MongoDB instance, you'll see a new database called Catbook, or whatever name you gave it. 2 collections, one called comments, one called stories. And every single one of those fields will have all the stories and comments that you that your Catbook has had. You need to run npm install.env because it's a library to load environmental variables. This specific branch does not have that dependency, but you do need to run npm install.env if you want to use environment variables. As a recap, today we learned how databases are structured, more specifically MongoDB, how to connect to it from your backend, how to interact with the database via an API and Mongoose, and how the front end will interact with the backend. And that's about all you need to know about MongoDB. Of course, you can come to office hours if you want to know more fancier things that MongoDB could do. But just for reference, you can look up the MongoDB documentation, the Mongoose documentation, if you want to do anything fancier than just retrieving documents that follow some fields and values. And yeah, so it's Friday, so you guys can leave. There's nothing after this. Shannon or Nick, if you guys have any announcements to make, feel free to shout them out. I will stop sharing my screen. Yeah, you can see the server code. Let me reshare my screen. Here. So you don't need this step. This one's just me just telling you guys how to do more things since I have extra time. I don't know what that's doing to everything. This is using the environmental variable instead of just a string. And you have to use the .env library for this. And we got it to the .env file. And this is where your actual SRV is at. I'll leave the questions doc open to see if you guys have any more questions. Also, if you guys want Puka Puka to do fancier things, post on Piazza. I need to do something with my life over winter break. Also, one thing. So sometimes you will get this error. So when you run the hot loader, it uses port 5000. If you try to run the hot loader again, it will fail, I believe, because it's also trying to use port 5000. And only one program can ever listen to the same port, I believe. So when it tries to, when two different programs or 2 different instances of a program try to run and listen to the same port, they will fail. This is compiled, but it's not being served. Really weird. My code's just that good, I guess. Well, anyways, if you ever get some weird error that says something like address is being used or error address is used, you can run this command. This one's a dangerous one, but this is how I fix it. So pkill is a command line tool on Windows and Linux to kill programs. And if you click this, it will kill anything that uses node.js. As a side note, VS Code actually does use some dependencies on Node.js. So when I run this, it will actually kill VS Code. And this is, I have to do this sometimes, but after a little bit, it works. And this will like release all ports that are currently being used. That way you can restart your program and actually listen to a port. And the most common way that this happens is by you clicking, by you just closing terminal. So if you do like, instead of hitting Control-C, if you just click like the X button, it will not guarantee that the port is freed. So if I do like npm start and then just close it, port 3000 might be stuck. And when you do npm start and no other terminal windows are open, it will still be blocked. Okay, so that's it for code. Remember the milestone 1 is due by midnight today. Milestone 1, you just need to sign up for a slot. We'll be talking to your teams all the weekend, through the whole weekend. And by the time you guys meet with us, have some wireframes or some wireframes and be able to walk me through what your site is.